The stage is yours. Thank you.
Thank you. So, good afternoon, everyone. Talk number 3. I hope you still have some energy left. Of course you have, right? Yeah, that's a good point. I want to talk about AI in the media and entertainment industry, how we leverage that. So, there's a saying that multimedia is everywhere, and multimedia is maybe the fastest growing technology in the recent years without even being recognized, right? So we have the smartphone, cameras everywhere. We generate pictures for social media in millions and trillions of items. We share them on social media. With short form videos, even more video content out there, and all this need to be managed by media and entertainment companies. But if we look at these conferences and the previous talk, everyone is talking about AI now, generative AI. So you could say that AI is everywhere, right? I don't want to talk about Gen AI. I'm talking about the classic AI or machine learning parts we use in the M&E industry. And but still it's the intersection or the application of both in the thing. So I would say multimedia is everywhere. So who am I? As have been perfectly introduced. Thank you for that. Computer scientist. Somehow working on a research project about multimedia information retrieval that dragged me somehow to pursue my PhD. But this is another story. I'm working with cloud solutions since ages, at least at the beginning of that. And I'm working as a consultant at Qvest, consulting M&E companies, basically. So what is Qvest? You may have heard about it. We are a consulting and system integration company, globally active, working with many large M&E customers. And we build digital products to make good customer experiences for their services. And we also work with the organization to build or to develop exceptional customer experiences. So even in the topic of AI or machine learning, we are talking about ML ops or data mesh and stuff like that. These are all also organizational changes in development organizations. But enough of that. So let's have a look into the M&E industry. What's going on there? What's changing there? So of course, everything is all about entertainment. So the M&E companies want to create entertainment experiences, keep you watching and experiencing, listening to their content, basically. Of course, they're also interested in growing subscriptions and consumption and ad revenue. But more, they're focused on creating entertainment experiences. And this market is in a change. Still 40% of digital revenues is created in the M&E industry. And this is expected to grow to over 60% in this year. So it's a growing market. And more players are entering this market. Think about Disney or Paramount launched subscription services recently. Not necessarily successful, but you have more competitors in the market, more content is there, and these examples show that it's not all about high quality content. You have to create good experiences to keep your visitors, your audience watching and listening, starting them binge watching, recommend them the cool next videos and stuff like that. So this is what we are working on, and how do we apply AI in the media industry? So we will have a look at the digital media supply chain, which is basically the process of how things come from the recording studio to the Netflix or whatever shop front end. So there are different stages, like the capturing and editing process. Then somehow capturing can be digitalized film rolls. Still this happens. Then will be transcripted. Quality control need to be done. So there are several steps where people actually watching the movies and find some technical artifacts, leftovers from the transcoding, checking if the subtitles are correct, checking several things. So this is a typical manual process. We have things like digital asset management. Somehow this new content need to be inventorized. Like also this, if you think about a news agency which is producing short form video, 200 videos a day, this all need to be inventorized and preserved for in the archives. And you still need to be searchable and manageable. There comes metadata into play, so to describe all the contents, and then we have several steps like the DRM, and until this went over to the digital service provider, so more or less the shop front end, where it then can be watched by the audience. All right. I want to show some use cases with AWS services. I selected AWS because of the color matching, but we as a company still work with other services too, and I wouldn't say that these are the only services you can use, but to have some examples what you can do. So we will talk about different services like AWS Rekognition, personalization, Transcribe. So these are not these fancy Gen AI models we have seen before, but classic machine learning tasks. So we can map that to the digital media supply chain, but let's directly jump into the use cases. So the first use case I want to describe is in the editing phase. So think about that there is a lot of interviews or things filmed with people talking about something, and in the editing process, usually you have to cut it to the end movie, and then you have to watch it. With Transcribe, we can just transcribe the audio of the video, and then we can use Transcribe-based editing. So you can see here, then we have the transcription. You can see that we have pauses in the text. We can cut that out. It's much more easier to cut based on the text. If you can see there are some erms or pauses in the text, than to listen to the audio of the raw material. So this is a really easy use case. But still you have to integrate that into an application or web application to make this usable. So it's not just transcription. Of course, you still have to prepare the visualities of pauses and stuff like that. If you have several speakers, you have to visualize that. So you have to prepare that from the transcription to the user interface. Next up, we have the quality control. Usually, as I said, it's a manual task, so people are looking and watching to the movie and check if there are some things, maybe do ratings like nudity and stuff like that, and checking that in the video, and checking if there is some text. So you know if there's a movie where it's maybe an English movie, but there's a discussion on French, then they print in the subtitles for the language in the movie itself, so it's not a separate file. So this need to be checked if we have the German version of this movie, that there are German subtitles and so on. So this is also everything manually checked. And with transcription or AWS Rekognition, we can automate that and check if the subtitles are in the language we expect. Also the audio lanes in the different movies are in the expected language, things like that. This helps to reduce the cost of the manual control. The AWS services are really helpful here, so we can put in the raw material, the media asset, if it's a video or audio. We put in the parameter set which we want to recognize or want to transcribe, and then we have the asynchronous processing and can evaluate the result and check if it's what we expect or not. Next is the big thing is the metadata enrichment. What is metadata? We usually have three categories of metadata. We have the first, it's administrative data or metadata, where it's all about technical things like aspect ratios, resolution, stuff like that. rights management, so where, in which countries is it allowed to play this kind of media and things like that. We have structural information like chapter marks for movies or scenes, maybe in podcasts. We have also some chapterings, the structural information, and we have descriptive metadata. This is the most important, even if it's the smallest block here on the slide. This is describing the media asset to find it if you look for it, or if you want to search for it, or if you want to do a recommendation based on that. We have simple metadata which can be entered manually, but we also talk about semantic metadata, because think about if you have a movie or a media asset about a jaguar. So what is it? Is it the car or is it the animal? So this is where semantics come into play to decide which category it is. Or if we have more complex scenarios, which we'll come back later on, we want to store that as semantic metadata. AWS Rekognition is helping us here very well. So it has a lot of possible use cases. I don't want to go to each of it, but I want to highlight that it works well on images, stored video, and also in some cases on streaming data. So for some cases for a news feed or live sports thing, we can immediately use this streaming data to do things like object recognition or facial analysis or identity verification. Where we use it in the media is for sure for segment the video into chapters. Not a fairly easy task. The technical part is maybe easy. You can just detect something like black frames or so inside the video, or technical things like the SMTPE color chart for in front. So this is what you can detect easily. It's a bit harder, but Rekognition does it very well to detect the scenes in the movie, so that you can detect, okay, the end of the beginning and the end of a movie scene and put that into a chapter. So I'm not sure how it's for you, but for me it's really annoying if I'm watching some kind of a TV series on the couch and then sleep in, and then the next time I have to scroll from 0 on my big screen TV to the place where it stopped. So it was really a better experience to have some chapter marks to move on. So we have the structural information then we do some kind of object detection usually to identify things in the movies or in the video. There's a lot of different labels which AWS Rekognition can detect. Not just recognition objects, also things like emotions. And we can derive the metadata from that. So we have just a simple feature extraction we can understand. So same process as I said before. We have the media asset, a parameter set, and then we have the async processing and have the result. But yeah, maybe another example for the movie thing where we can then see for each segment we found in the TV series, we can detect or predict the mood of the different chapters, and then we can summarize that to the overall mood, which helps us later in the recommendation, things like that. So again, here we have some quality control of user-generated content. For a lot of, or in the movies or in TV series, this is some official process where it gets age-rated, at least in most countries. For user-generated content like podcasts, this is not the case. So basically everyone can create a podcast and distribute that. And if you want to provide these user-generated content, it's the same with, we heard from Alexa, you don't want to play some kind of not kids ready content to certain people, or maybe even things like hate speech or whatever. So there's also a service within AWS Transcribe we can use. There's an included toxicity detection, so it can detect different kinds of things like gibberish talk or sexual harassment, things like that, and it gives you some information about that, how likely it is that the content contains such information. Also, summarization is a big thing. If you want to summarize or create summaries for your video portal, then you can also use Transcribe in the same step, create with SageMaker a summary. Of course, nowadays you can use also AI, Gen AI, to do this. Yeah, so this is also a use case. So thinking about the process of organization. So we have many different blocks, many different services in the cloud providers or so, but we need to somehow make it easy to process it. Is it easy just to get the result? The result is just a JSON file with some more information than just the transcription or things like that. You have to interpret it and to process it. Then there are some other things, so you don't want to analyze it twice because you will be charged twice. It's not easy to do all of the analytics in the same step, but you still want to minimize that in your process in the digital media supply chain. So there are several tools to do this. Of course, for AWS, you can use serverless things like the step functions, SNS, SQS processes, or connect them with Lambda services. There's also a tool which we provide from our company, KIP. It's a no-code integration platform, especially for the media and entertainment industry. But there are other products like SDVI Rally as well. But still, if you have the metadata generated, you have to efficiently store them to use it in a search. And this is where my research come into play. We have learned yesterday that you can use graph structures to organize the data. And this is something which we do as well. If we have a semantic understanding of the metadata, we can organize that in a graph. So we have the detected features here, like Jane, or a head and a head. A bit confusing. And we have relationships between these features, so that we have Jane and Jane's head, and on the head or above is a head, as you do it. And we have this semantic data, and we can, of course, model different kind of relationships and kinds of metadata and connect them. And this is what we call a multimedia feature graph. And this is a very flexible way to describe the media asset. So we have now this representation of the media asset. And next, how can we search for it? Graphs can be stored in graph databases like Neo4j or also on AWS Neptune, but they are fairly slow to search on. So graph algorithms take a bit of time. And of course, we want to search for it and want to have a result in a second, not in 10 minutes or so. So for really large multimedia collections, we need a better way to search for it, an efficient way. So we somehow created graph codes for this problem. And this translates this graph into basically a matrix. So it puts in all the nodes as vocabulary, and all the relationships are type coded. So if I have a relationship, I put in some number, and depending on the type of the relationship, it gets a special number. And in the end, I get a vocabulary and a matrix. And this is really helpful because comparing matrices is fairly easy and really good to calculate, something which you can parallelize heavily. It scales nearly linear with a media collection size, so it's a really effective way to search for the data. So, yeah. Now we have the semantics. We know that there's a Jaguar with the animal or the car brand. We have a lot of media in our collection, and then we can search for it for similar items or recommendations. Talking about recommendations, the next thing here is that, well, yeah, typical thing for a media or a Netflix or whatever shopfront in the media industry is that you have some kind of a recommendation, what to look next or what's interesting for you. And AWS Personalize is a tool which helps you on this side. So based on the asset data and the user data, as well as the interactions, like what you have watched or what you have clicked or what mood you are in, you can create together with the receipt based on, so it basically says if it's an item-based affinity or something for the user personalization or personalized ranking, related items. So this, what do you want to recommend? There are some predefined receipts which you can use together with your data to train a solution, and then create a campaign which basically provides you an endpoint which you can request on real time. So this user is in this mood, please recommend some items. Of course, there's some additional thing what you usually want to have, because it's not just a recommendation. You also have bought the content usually, so you have paid a lot of money. So you may have some promotional campaigns you want to give into that. So you want to do some kind of a re-ranking that you put in your new fancy TV series which you want to promote in front. Another thing is improving the engagement in the user portal. So who of you is a sports fan? Raise your hand. Okay, see some, not many. If you follow your sports, you maybe have you're a fan of a club or a dedicated sports person. And if you maybe watch a soccer game, or you're a fan of a club, do you want to have a notification on your phone while you're watching the game? Because think about, maybe you're watching the game on video on demand, which has some delays. So you get your notification of the goal before it happens in your live game? Or at least would you call that a good experience? I don't think so. So the other way is if you cannot watch the game live, but you want to watch the real life, but so you are enjoying the nature instead of watching the game. Do you want to receive the notification of this? Or do you want to know the end result of the game before you watch the real life? Maybe, maybe not. There are different opinions or different types of people. And this is where Pinpoint comes into play. If you want to customize what kind of notifications you want to send to a certain customer group or customer segment, this is how this can work. So you have the audience management, where you see the settings for the personal preferences of the user. Can enter that to Pinpoint. Then you have an endpoint where all the event data from the game is coming into, or streamed into, will be processed, and then based on the customer segment, Pinpoint can decide who gets this notification about this new goal or the end result of the game or whatever happens in the game. Right. We had some problems streaming a lot of these data in one use case where we used Amazon Managed Kubernetes, because of the customer has 1 million daily visits, so a lot of user interactions. And if you send an event for each user interaction, like clicking or scrolling on different items in the app, so this produces a lot of events, which you want. But this ingested the ingress controller of MKS. So we needed to find a different solution here. So this is where, if you have a lot of traffic, so still these services are scalable, but not infinitely. All right, this is where you can create cool user experiences. if you collect data like the events or the click rates in the application, you collect a lot of data. So somehow, what to do with it? AWS SageMaker is a tool here which makes machine learning application fairly easy to a certain extent, but it provides some kind of a no-code user interface to help you without any larger experience to create machine learning models. So it helps you if you have, for example, the CSV files in your S3 bucket. It makes it easy to load this data. Has a data explorer which can show you some statistics for different types of the data. Allows you also to join different sources. Select if you want to maybe predict something, like here. It's hard to read, but it's the target column here is the actual shipping days of the data set, so to predict how many for different orders or different services, how many shipping days you can expect. And basically you enter this data, select the column, maybe you choose, it helps you to choose which columns to include in the training of the model. It provides you with some suggestions, and then you can train the model and predict that without entering any Python code or stuff like that. So especially for people who are not very experienced in this field and want to play around with that, so SageMaker no-code is a good starting point. Of course, you can expand then with other things, so it's a SageMaker canvas. You can then extend to SageMaker, Jupyter notebooks stuff if you want to go deeper into the data and create more customized user experiences. All right, one more thing we experienced in the M&E industry. If you have a subscription service, you maybe provide something like a 30-day free trial, which is good for the customers. They can test the service. Unfortunately, with GDPR, the customers after 30 days can request the full deletion of all their data. So afterwards, they can then re-register and try 30 days again. This is something which you want to avoid. We've seen this especially for some football games in this video on-demand services, where you have spikes when there's the favorite club playing. Then the people register for free, and then afterwards they want to try again. So AWS Online Fraud Protection is one way to address this problem. Also, you can collect the data, the user data you have collected in your IDM system, in your registration process, and can train certain solutions to predict that. Maybe there's an easier way. Even with GDPR, you're allowed to store anonymized data. So if you somehow hash the email address used by a certain user, you can. This is anonymized. You can store it and check if there's a new registration. You check against this blacklist database, basically. This is the easy way. With online fraud protection, you can create much more, better, more advanced solutions. Okay, and of course, what you want to do then is triggering a rule to do whatever you want, either blacklist the user or get in contact with him, maybe make him an offer. So it depends also, again, on your kind of user experience you want to create. Either you want to be the bad guy and say, I kick you out, or I make you a special offer and maybe you get a new subscriber then. In conclusion, so there are a lot of solutions available as a service, not just in AWS, but AWS has a lot of them. And it's, of course, worth to digitalize and automate your manual efforts. Of course, this is all the use cases are things which have been done manually or executed manually and can be automated, which is important to decrease your cost, provide better offers for the subscription pricing. And of course, I'm not sure, but if you are someone who need to look videos all day long to enter metadata manually by hand, this doesn't sound like a nice job or fun job. And yeah, create awesome customer user experiences is an important part because this is what your customers want. And this, especially in the media industry, it doesn't help to just make your media collection publicly available. So you need to create experiences to drag people. And AI helps to make this trick work. That's it.
Thank you. Thank you, Patrick. Round of applause for Patrick Steinert.
Thank you.
Before we move on to the serious questions, did you make this presentation especially for the audiences in Romania? I'm only asking because I saw Love Island there, and apparently it's a phenomenon. All my friends are watching it here in Romania. I can't get...
Okay.
Yeah.
That was not.
Right. So do we have any questions from anyone in the audience? Anyone planning on building the next and better Netflix? No? Yeah, we have someone there. Okay. Ambitious.
Hi, thank you. So I want to ask, if you use machine learning to get all this metadata, how do you make sure that in time the metadata is correct, quality is and valid in time, if the model will not generate something wrong?
You can just do it to a certain extent, right? So they're usually the detected or predicted features are provided with the confidence. And depending on the filters of inclusion or exclusion of the features AWS Rekognition can expect. So this is something where you have some control to a certain extent, but you cannot be completely sure that it's perfect. So it's machine learning, right? So it's just a prediction.
Thank you.
Thank you. Any other questions? Yeah, we have someone here. I'll give you my mic. Thank you.
I was interested if you are doing performance tests. So imagine that you have a match or a football and you're streaming a lot Netflix or other things. How you proceed with this?
We hadn't done performance tests on our side for a use case. I know that AWS has a reference use case for that. They did it with Deutsche Bundesliga with an app, but I'm not sure how many users there are, but I think in Germany there are many. Okay.
Thank you. Anyone else? If not, I have a question for you, seeing that there aren't many people here wanting to build the next Netflix or Disney or HBO Max. I was wondering, a lot of the solutions that were included in your presentations, maybe they could have other use cases, like could they be used for analyzing large volumes of security footage, for example? Or is there somewhere else we can apply these tools and your learnings into different businesses?
Yeah, it's transferable to different domains. So one we explored, especially with the multimedia feature graph and the graph codes, is about the medical area. So there, with all these X-ray images and MRI imagery data and also videos from certain imaging, need to be collected and evaluated, especially for machine learning training. This is where it's also useful to work with this data. A lot of things is happening in autonomous driving as well, where you know these cars have a lot of camera imagery, and also for the evaluation in this area we need a lot of feature extraction store the metadata to find different situations you are looking for. You maybe want to look in a certain traffic situation before an incident or stuff like that. So therefore, you need to find the media asset in all of the million parts.
Thank you. Let's try again with the audience. no, these guys need a coffee.
Yeah, I think so.
I'm not giving you a coffee break yet. Just one more question. I know you haven't touched on this at all in your presentation, but I see it somewhat related. I'm talking about generative AI and using it to create new pieces of video content.
Mm-hmm.
Do you see that as something that could happen in the future with large streaming platforms? And I'm not talking about 2 or 3 minute videos. I'm talking about TV shows that are created mostly using generative AI.
Yeah, possibly, yes. Of course, it will take some time to produce a bit more better content of moving images. So right now it's all about creating single images and then merging and morphing the images to create a video from that. But in the media industry, you typically have low cost or low value content or high quality content, low quality, high quality, where I think that low quality content will maybe more generated by AI in the future. Still, for high quality content production, you need the humans.
Perfect. Thank you so much. Round of applause for Patrick Steinert.